Hi everyone, welcome back to the channel. Now today we're going to be talking about biases in AI. Now AI systems have been coming into more and more of our daily lives, and we want to make sure that these systems are not biased. We don't want these AIs to make incorrect decisions based on the information that they have. You don't want them to uh, you know, give results that may not accurately be like a more stereotypical result or a bad result that ends up perpetuating biases that we have. So that is kind of what we're going to be talking about today. We're going to go through sort of some examples, types of data bias that might come into machine learning, and then we're going to talk about some examples of biases that exist in certain models that are out there, and then we'll talk about ways to avoid bias. And then I'll wrap that up with a conclusion, sort of my thoughts on biases. So this is sort of a video in the topic of AGI, but really it's in all AI and all machine learning. Is we want to create software that is respectful of everyone, and also not jumping to generalizations like humans might. And let's start by seeing some really basic examples of why we don't want biases to exist. And things like Apple trying to remove any biases from Face ID. Because if you have a software unlock system using a face and it's unable to identify different people's faces, specifically to different races, then you're going to have an issue because everybody's going to be buying that phone. You don't want to just tailor to a specific audience. And I think this is a good example of why we want to get rid of biases, is because we want everyone who purchases a product or uses the software to have the same experience and to not be able to experience that software or hardware. Of course, it is also very impactful in things like healthcare. When we train on different types of bodies, there are a lot of different types of generalizations. If we train on a specific type of data set, like let's give an example of white males, it might not generalize to females or to people of other races, because even though we might think that training on a large data set might be able to help, if we're training on a specific type of people or a specific set of people from an area, it might not generalize very well. And that will be very problematic when people need to receive, life changing or they're in life threatening condition. They need to receive care fast, and the AI makes a wrong decision or tells the doctors the wrong locations of where to do surgery. That will be catastrophic. So that's why we want to remove biases in AI. And also, like Elon Musk also is in the news about making another artificial intelligence startup to counter ChatGPT, and he's going to call it based AI, and he wants it to be less woke, is what he says. And so we will see sort of what he does with that, but it is generally very good to make things, open source or like more open and transparent, and I think that's what he wants to do, but we'll see if he actually follows through on that. But yeah, let's go on to the types of biases, data bias that exists in machine learning. And this website is pretty good and gives 8 types of bias. The first type is systemic bias, basically when certain social groups are favored and others are devalued, as it says. And one of the examples it gives is like the infrastructure of daily living isn't adjusted to the needs of disabled people, and that is a good point. I've seen I think in recent years there's been a lot of push to add things like ramps or automated doors, and these are things that not only help disabled people, but it also does help everyday people. In fact, walking up a ramp is a lot easier than walking upstairs, and you can sort of drag things like wagons and other things that you might have to carry with your hands on stairs. You can just drag them up the ramp. And also, if you're carrying a large amount of objects, automatic doors are very helpful. So sometimes eliminating these systemic biases do help everyone. Automation bias is basically when you take AI-based recommendation and use it before verifying the information is correct. So this is kind of like a feedback loop. Basically, the AI is already biased. It thinks you want certain thing, and then you just assume it's right and just use it. And this kind of happens a lot and this is where you get things like reinforcement and going down a rabbit hole and things like that. Is you kind of sort of just assume the AI is right, and that's really bad because you're not actually helping the AI learn anything. It's just sort of thinking it's always right. Selection bias is basically if things are not when the data isn't randomized, you're gonna have selection bias. So you want to have data picked randomly, so it's trained randomly and it's learned randomly rather than learned in a sequential order. Although if you learn it in a sequential order, it's gonna learn certain things first and learn different things last, and then it'll sort of develop a bias, and that's really bad. Okay, overfitting and underfitting are two very big things that people in machine learning talk about, and this is sort of good to understand conceptually for those who are not in machine learning. But basically, overfitting is the idea that you are making your machine learning algorithm return the exact values of whatever you're training on. So for example, you can see over here, it is exactly returning it's exactly dividing all the circles and all the x's by one line. And even though this may seem very good, particularly in your test set, you might have 100% accuracy in this case. If you introduce variables and data, like let's say there's an x right here, or like for example, let's just say for some reason an O falls over here, then you would have fit to the test set this specific thing. So your test set could be biased and it is fit to that. And then when you go to a unbiased or real world set, it's seeing new data that it didn't know about, it would make some wrong choices. And underfitting is the opposite, is basically you are too general and basically, it's kind of useless. So yeah, you want this sort of appropriate fitting, basically being able to separate out most of the classes correctly. You don't need to separate out everything in the trained class correctly. That way, when you move your AI to the real world, it will hopefully work 90 or 99% of the time. Reporting bias is the inclusion of a subset of results and analyses. Basically, you would probably pick and choose different types of data to include based on what you're interested in. For example, analyzing data based on studies found in citations of other studies, or excluding reports not written in the scientist's native language. So just ignore everything that's non-English or specific language, and choosing studies with more positive findings rather than negative findings. So you're biasing towards things that are good and not bad. Overall generalization bias is basically assuming everything that you see in the data set will be seen in another data set. And that's very bad because you're assuming things are true and stay constant. Group attribution bias is basically stereotyping, I think. It's just that you assume an individual characteristic is influenced by the group that it's in. And that is exactly stereotyping. And that's really bad because we all know that stereotypes sometimes can be a good way to very quick make snap judgments, and that's why people do it. But most of the time, it's not good because stereotypes usually are kind of not respectful of people, and a lot of times people just don't fall into stereotypes. And finally, we got implicit biases. Basically, this is probably the one that's people can most relate to, and that is including things that we personally believe in, or making our AI, designing our AI in a way that responds the way we think it should respond. And a lot of times it's okay to do that because we might be unbiased, but a lot of times it's not okay because the views that we hold may be biased and we don't really recognize that. And when you train your AI to behave like yourself, you are also inherently making the AI inherit all of your biases. So this is sort of the biggest point that a lot of people think, and this is sort of the point that a lot of people are making, like different AI might be leaning towards a certain political affiliation or another, is that they think that the people who trained it are influencing the AI to respond a certain way. Okay, let's move on to some of the recent examples that of bias and why it's pretty bad when it actually affects AI outcomes. So one of the people tried the portrait AI thing. Basically, portrait AI makes images into portraits, and this is apparently on Obama, Oprah, and Laverne Cox. And you can see, it is definitely very biased towards white-skinned people, and it makes people very, very fair-skinned. Also, state-of-the-art models do exhibit bias as well. And this one, I think, is using things like DALL-E, Midjourney, and Stable Diffusion. Here is a prompt saying attractive person, and these images of attractive people are more or less, what, quote, society holds a beautiful ideal is. And specifically, it might be, the people who write news articles and the people who set these ideals. And this might not be the ideal for everyone. Some people might not find these people attractive, or they might find a certain different type of people more attractive than others. And also, I think, whether this is also a good example of American man and his car, an African man and his car, American man and his house, an African man and his house. And this was basically a very good example of hey, look, American man has, I guess, a decently nice car. I mean, this is a black and white. This is probably from the 1900s. And American man has a nice house, a big house actually. This is pretty big. It's 2-story and a nice lawn, whereas an African man has, I would say this is a pretty beat up car and a pretty barren house and in the middle of the desert. And that's not really accurate because it's sort of a stereotype of people in Africa are probably more poor and people in America are more rich. And it's definitely not true because there are American people with more beat up cars and American people with worse houses. In fact, I don't even live in a 2-story house. And of course, in Africa, a lot of places there's more than enough examples of very well developed cities and very well developed places there that do not look like this. Like if you go to Africa, obviously there are places that do look like this, but there are places that don't look like this, and by generalizing this and training data, you can see that the bias is showing through. And this is an example of DALL-E, between a disabled woman leading a meeting and a blonde woman leading a meeting. The disabled woman, I'm assuming this is what DALL-E thinks a disabled woman is. Obviously, we don't know for sure if it also recognizes this as a disabled woman, but mostly it's putting the person in the wheelchair as sort of listening to the meeting rather than actually giving the meeting itself. And here's a very good representation of bias where different things, different occupations are being vastly portrayed one way or another based on gender. And things like software developer, most of them are white men, and I've actually seen that myself. I would say nearly all the pictures are probably men, and a lot of them are white men or Asian men. And then for things like flight attendant, therapist, nurse, housekeeper, you can see that a lot of these skew the actual the generated images are much more than the actual percent of occupation that is woman. So you can see flight attendant is basically all female generated, nurse, housekeeper, same thing, but they are maybe 80% or 60%, or even cooks are below 50%, and it was greater than 50%. So yeah, there's definitely a lot of biases in image generation programs. And I'm going to go down to how to fight back against AI bias. And I think really the best way that we can fight back is to make a good data set, to basically gather as much data as we can, to incorporate a diverse data set. And the idea is that we want to make sure that reducing bias is one of our main goals when making an AI model, because it's very important that all of our software is able to be used by everyone and everybody feels like that they are accurately represented by the models. It's never good to make AI biased, and I hope everybody agrees that AIs should be unbiased, should be transparent in how they decide things, and also make sure that everybody can use the AIs. We shouldn't be sort of making people feel bad for adjusting to biases. Obviously there are concerns that we're going too far, and that is a discussion to have, but in general, adjusting for bias is very important. And we'll move on to sort of 5 ways to minimize bias. And one of the first ways is to choose a good model um, as a base. And, there's supervised and unsupervised models. Basically, supervised is when humans put in input. And if humans are putting in input, we need to make sure that the humans putting in the input actively recognize their bias and don't feed that in, because whatever you feed into the model, it will learn. And for unsupervised, we need to make sure that the neural network learns by itself to figure out what is biased and what isn't, and so that it doesn't develop the bias sense of the data. Of course, number two is using a good training data set. And as I said before, you really need to make sure that your data is comprehensive, balanced, and replicating real world scenarios. And you don't just choose data sets that are readily available. In fact, a lot of data sets, are generated, sort of in the Western sphere. So a lot of the East Asian countries or Asian countries or African countries who want to develop AI need to get their own data sets, because if you train it on a Western data set, it might not reflect the values and the more importantly, the different types of people that interact with the AI might not really be compatible. So that's why it's important to have a diverse data set always. Of course, processing the data is very important, and that's a big part of making an ML model. And this is where human input comes in. We can throw out data that we might deem unnecessary that will further the bias of the model. So when we're processing data, we need to make sure that we stay unbiased and that the data stays unbiased and diverse. Number four is to monitor real world performance across the ML lifecycle. It is very important that software developers and people who deploy ML make sure that their software remains unbiased in the real world. We can train it as good as we can, train it and test it in the lab and make sure that it's unbiased. But when we put it out in the real world, it might have a different reaction. So we need to make sure that it doesn't become biased when we're using it in the real world. And finally, the infrastructure issues. Infrastructure, if you capture it in different types of infrastructure, it might introduce biases based on those infrastructure. And I think that that's probably more biased towards, if we're using newer phones and newer technology, we can't really generalize those sensors to older technology. And that might introduce bias in that way. So in conclusion, I hope everybody learned a little bit about examples of biases, sort of how they get introduced and how we can prevent it. And I think it's very important that everybody tries their best in reducing bias, because that's basically what can make or break a model. It might work for the specific type of people or a specific type of group of people that you targeted your machine learning algorithm for, and it might be wildly wrong with a different type of people. And that's really bad when you're trying to make a product for everyone and when you're trying to make products that affect everyone. If you have a suboptimal experience for certain types of people or certain or if the machine learning algorithm learns a certain feature, it might make bad decisions. And that is especially important when we are trusting AI to do its job in more and more places, and as we move towards things like AGI. So I hope you learned something in this video. I tried to keep this a little bit shorter. Uh, if you liked it, make sure to press the like button and subscribe and share this video. Leave a comment below if you have anything to talk about regarding bias. And I will see you guys in the next video. Talk to you later. Bye bye.